Hello all. So we are going to discuss about the microprocessor LED display. Our aim is to write the ALP to alternately switch on or off a green and red LED within a small time interval and to execute using 8085 kit. So before going to the program, let us discuss about the theory of microprocessor. So here it's shown the pin diagram of Intel 8085 and pin diagram of 8255. Okay, then Intel 8085 is an 8-bit NMOS microprocessor. It is a 40-pin IC package fabricated on a single LSI chip. The 8085 uses a single plus 5 volt DC supply for its operation, and its clock speed is about 3 MHz and the clock cycle is of 320 nanosecond. Its accumulator and data bus has an 8-bit data, that is 8-bit of data can be transmitted in parallel to or from the microprocessor. The 8085 requires a 16-bit wide address bus as the memory addresses are of 16 bits. The 8 most significant bits of the addresses are transmitted by address of A bus. The 8 LSB of the address are transmitted by address or data bus, that is the AD bus. The address or data bus transmit data and address bus at different moments. At a particular moment, it transmits either data or the address. Thus, the AD bus operates in time shared mode. This technique is known as multiplexing. Next, the Intel 8255. The Intel 8255 is a programmable peripheral interference, that is PPI. It has 40 pins. It has 3 8-bit ports, namely port A, port B and port C. The port C has been further divided into 2 of 4-bit ports, port C upper and port C lower. It has 3 modes of operation. They are mode 0, mode 1 and mode 2. Mode 0 is a simple input or output. In mode 0 operation, a port can be operated as a simple input or output port. Each of the 4 ports of 8255 can be programmed. Next, the mode 1 operation, that is dropped input or output. The port A and port B both are designed to operate in this mode of operation. When port A and port B are programmed in mode 1, 6 pins of port C are used for their control. PC0, PC1 and PC2 are used for the control of port B, which can be used either as input or output port. If the port A is operated as an input port, PC3, PC4 and PC5 are used for its control. The remaining pins of port C, that is PC6 and PC7, can be used as either input or output. When port A is used as an output port, pins PC3 and PC4 and PC7 are used for its control. The pins PC4 and PC5 can be used either as input or output. The third mode of operation is mode 2, which is the bidirectional port. It is a stopped bidirectional mode of operation. In this mode, port A can be programmed to operate as a bidirectional port. The mode 2 operation is only for port A. When port A is programmed in mode 2, the port B can be used either in mode 1 or mode 0. For mode 2 operation, PC3 to PC7 are used for the control of port A. This is the program to be executed for the glowing of LED. Okay, the first column is the memory address, and second one is the machine code, third one the label, fourth one mnemonics, next one operands, and the last one the comments. Okay, here one of the LEDs say red is connected to any of the 4 lines, that is PC0 to PC3, and the other LEDs say green is connected to any of the lines PC4 to PC7. Okay, the stack pointer is initiated since subroutine is used. For time delay, control word 80 is loaded in control word register to configure all ports as the output port. The program enters a loop 0 in accumulator to make 4 LSBs high and 4 MSBs low. Now out 02 is executed. Then now PC4 and PC5 carry low voltage, so the red LED shines and the green LED doesn't shine. A suitable large number of FFFF is loaded in DE pair. This number depends on the required delay time. The delay subroutine starting from 0B is called subroutine. The control of DE pair is determined in a loop. After each decrement, control of both D and E are logically odd only if the control of both D and E are 0. The result of OR operation is 0, otherwise the control goes beginning of loop 1. The repeated execution of loop 1 is continued until the content of DE pair becomes 0. Now result of OR operation is 0. Control goes out of loop 1. RET return is executed next. Control returns to main program. Next 0F is loaded in accumulator. This is sent to port C. Now the A lines PC0 to PC3 carry low voltage and PC4 to PC7 carry high voltage. So green LED shines. The process of alternating sending of O0F and F0 through port C and delay subroutine is repeated. The port address are for port A the address is 00, for port B the address is 01, for port C it is 02, and for the control or word register the address is 03. Let's go through the program of execution. The memory address, it starts from 8000 and continuously to 8018, and then the subroutine starts from 8100 and ends in 8112. The initial step is to load that. For this we use mnemonics, we use the instruction LXI, and then MVI for move. Then we use when we give the instruction out, and then MVI out, then we call the delay, then again MVI, then out, and again we call, then jump, and then halt. Then we are starting the subroutine. Also please go through the subroutine program. And then after typing the program, we execute it by connecting to a breadboard and LED. After doing the connection, we execute the program. So if the program is correct, we can observe that the LEDs are shining alternately based on the time delay between the glowing of LED will depends on the delay time that we give to the microprocessor. So next we have to calculate the time period. For this we have to write the mnemonics of the subroutine program only. So first we have to do the first we know that the number of T states for each instruction, that is for the MVI instruction there are 7 T states, and for the decrement DCR instruction we have 4 T states. For the JNZ jump instruction we have 10 bar 7, either 10 or 7 number of T states, and again we repeat this. And for the return of instruction we have 10 T states. So for next we have to calculate the number of execution. The first MVI instruction it is to be executed one time. Then the next MVI instruction is to be executed 127 times, and then next one 127 into 127 times, that is 16,129. And then the decrement instruction is to be executed this much times, to 22,48,383 times, and then so on. Each instruction is to be executed this much times. Then we have to calculate the total number of T states, that is by number of T states into number of execution. So we get these numbers. Okay, then to find the total number of T state, we have to add these all. Then we will get this number. Then to know the time period, we have to multiply the number of T states into 320 nanosecond. So we will get 9.273 seconds. Okay. So that's all about our program, and the result is the ALP to alternatively switch on or off LED within a small time interval of time is written and executed. Thank you.